Welcome back to the channel. Today we are going to talk about a fundamental concept in modern software development, containerization. Containerization has changed the way we package and deploy application, making it easy and easier, faster, and more consistent. In this video, we will cover what is containerization, why it matters, and how it used. This is an easy, friendly introduction, and in the next video, we'll create a hands-on on containerization. Containerization. Sorry, my pronunciation is not that good. Okay, so what is containerization? Containerization is a technology that allows you to package an application along with all its dependencies, such as libraries, runtime, and settings, into a simple, lightweight unit called a container. Containers can then run consistently across any development and any environment from a developer's local machine to production servers. Think, think of containerization like a shipping container. No matter what goods are inside, a shipping container can be transported easily and handled by any ship, truck, or crane. Similarly, containerized application can run anywhere, regardless of the underlying infrastructure. Okay, the second thing that we need to talk about is the problem that containerization solves. Before containerization, developers often faced a dreaded, which called it works on a machine. Problem like this happens when an application works perfectly if one environment but fails in another due to differences in software versions, dependencies, or configuration even. So imagine developing an application on your local machine with Python 3.9, but when deploying to production, the server has Python 3.7, for example. The result errors. The result will be errors, bugs, and frustration. Containers solve these by packaging everything your application needs to run, ensuring consistency, access, environment. Okay, let's talk about how containerization works. So let's talk about the containers and virtual machines. This is the first thing we need to talk about. The containers are often compared to virtual machines, but they are quite different. Virtual machines include an entire operating system along with the application, which makes them larger and slower to start containers. To start, sorry. Containers, on the other hand, shared the host kernel, making them lightweight and fast. You can think of containers as more efficient way to achieve isolation. The second thing, Docker and containerization. Containerization. Docker is the most popular tool for containerization. It allows developers to create, deploy, and manage containers easily. Docker provides a standardized way to package your application along with all its dependencies into a container. For example, if you're working on a Node.js application, Docker allows you to bundle the code, the node runtime, and any required libraries into a single container, which you can then run on any compatible system. Okay, let's talk about the benefits of containerization. The first thing, we'll talk about the consistent environments. So with containerization, you can be sure that your application will run consistently no matter where it is deployed, whether it's your local laptop, a staging server, or production environment. Containers provide uniformity. The second thing will be the lightweight and fast. Containers are lightweight and have minimal overhead because they share the host system's OS kernel. This means you can run many containers on a single machine without the resource costs of running multiple virtual machines, for example. The second thing will be the portability. Containers are portable, meaning you can move them across different environments, like from your local machine to the cloud without changes. This makes it easy to develop, test, and deploy application in seamless way. Lastly, scalability. Containerization makes scaling application straightforward. Need more capacity? Just spin up more containers. Tools like Kubernetes can help managing container orchestration, making it easy to handle load balancing, scaling, and container health. So, let's talk about some common use cases for containerization. The first thing we use it in microservice architecture. Containers are perfect for microservices where each service runs in its own isolation environment. It's great in development and testing. Quickly create and tear down isolation environments for testing and development. It's great in the CI/CD, which is the continuous integration and continuous deployment. It's automate the process of building, testing, and deploying application with consistent environment. For example, in a microservice architecture, each service can be packaged in its own container, which allows for easier management, deployment, and scaling. If you need to update one service, you can do so without affecting the others. So, to wrap things up, containerization is a powerful tool that has transformed software development and deployment by packaging applications and their dependencies into isolated lightweight units. Containers provide consistency, portability, and scalability. Tools like Docker have made it incredibly easy for developers to use containerization in their everyday workloads. So, if you found this video helpful, make sure to like it, subscribe, and hit the notification bell so you never miss a video. And yeah, leave a question or any experience you have with containerization before. And thanks for watching.